Okay, good evening, everyone. So welcome back. This is actually our fourth session for revising for chemistry. And in this session, we are actually going to revise formula and equation writing. This is commonly the most difficult topic for most students. Okay, but really, is it so difficult? The answer is no. Okay, what you need is a few things. Number one, the periodic table. So right now, you should have a periodic table with you. Second thing you need is patience. You need to have patience to work out the formulas. The third thing you need is knowledge on how to write the formula, which is what we are here to achieve today. At the end of today, you must be able to write the formula of different compounds. Now, hopefully you realize by now, formula is like the chemical identification ID number of a compound. Very often, we will not say sodium oxide and spell it out. We would rather write out the formula of sodium oxide. It's just faster and easier. All right. Now, depending on whether the compound has ionic bonding or covalent bonding, the formula writing will differ. So let's start with the formula of ionic compounds. Now, how do you know if a compound is ionic? So take, for example, sodium oxide. Sodium oxide falls under ionic compounds. How do you know? Sodium is a metal, right? You know sodium is a metal because it's found on the left side of the periodic table. Therefore, you know it's a metal. Oxide comes from oxygen. Oxygen is a non-metal. How you know oxygen is a non-metal? Because it's on the right-hand side of the periodic table. So the moment you have a metal and a non-metal in a compound, in a substance, you know it's ionic compound. Okay? So what is this big deal about it being ionic? Ionic compounds contain ions. Ions have charges. So the first thing you do is you should go to the periodic table and find sodium. Sodium symbol is Na, right? Now, beyond just finding the symbol, don't stop there. Look at which group is sodium from. Sodium, if you look in the periodic table now, it is found in group number 1. Sodium is in group 1. Group 1 has 1 valence electron. It has 1 electron in the outer shell. And we know by now, okay, if the outer shell only has 1 electron, it's not stable because the outer shell is not fully filled. So sodium will lose 1 valence electron. Lose 1 valence electron. You notice Mr. So has written electrons as E minus. This is to remind myself that electrons have a negative charge. If I lose negative things in our life, I lose 1 negative electron. My charge is 1 plus. You lose negative charge, you become positive. So Na has a charge of 1 plus in the ion. Remember, this is ionic. So the ions have charge. Okay? Do the same for the other element in the compound. The other element is oxide comes from oxygen. Oxygen is a non-metal. It's on the right-hand side of the periodic table. But don't just stop there. Find out which group is oxygen in. If you look in the periodic table now, oxygen is in group number 6. Notice that 6 is written as Vi. V means 5, I means 1. 5 plus 1, 6. Now, if oxygen is in group number 6, group 6 means it has 6 valence electron, 6 outer electron. Again, 6 is not fully filled outer shell. Fully filled should be 8, but only have 6 now. Only got 6 electrons in the outer shell, so it needs to gain 2 valence electrons. So you notice the non-metal gains valence electrons. Electrons are negatively charged. I gain negative charge. That means it forms more negative 2 minus charge. Why 2 minus? Because electrons are negative, you gain 2 of them. So you become doubly negative. Okay? So like I said, you need to go through these steps of locating the elements, locating what is the group number, working out, does it lose or does it gain valence electron? Once you work out, then you know the charge. You must figure out the charge first. Once you have figured out the charge, your chances of getting the formula correct are very high because you realize that the charges are not the same. The plus and the minus are not cancelling each other out. The concept is in a formula, the positive and the negative charge must be balanced out. Currently, it's clearly not balanced. It's 1 plus, it's 2 minus. It's not going to be balanced. The only way it's balanced is how? Well, you look, oxide has a double negative charge. It's doubly negative. But sodium only has a single charge, meaning I will need a total of 2 sodium ions to balance out the double negative charge on one oxide. So the formula is Na2O. So the 2 at the bottom, this 2 is at the bottom. The 2 at the bottom indicates there are 2 Na plus ions. Why 2 Na plus? You need to balance out O2 minus ion. Okay? Can? So, important, you need to have some patience. Do not just rush into writing out the formula. I think the mistake that many of you also make is that you assume immediately there must always be 1 sodium and 1 oxide ion. That is not the case. All right? The way to deduce the formula is always to write out the positive and negative charges of each ion. And you do so by looking at the group number of the ions. Okay? Now, let's go with another example. So sodium oxide is one example. Next one I want to do is magnesium chloride. So again, we do the same thing. You must go to the periodic table and search for these elements. Magnesium is a metal, but don't just stop there. Magnesium is in group what? You go and find in the periodic table. Magnesium has the symbol Mg. Mg is found in group 2. So it's not the same as sodium, right? Sodium is in group 1, magnesium is group 2. We have learned group 2 has 2 valence electrons, so it will lose 2 valence electrons. Remember, lose electron means the charge is positive. It loses 2 electrons, therefore 2 plus. Let me write it in a different color. Okay, so it's Mg2 plus. That's the magnesium ion. Chloride. Chloride comes from chlorine. Now you notice for negative ions, the name changes slightly. Just now we had oxygen become oxide. Chlorine becomes chloride. So whenever you see chloride, anything ending in IDE is a negative ion. Okay, IDE means it's a negative ion. Okay, so now we're going to figure out chloride came from chlorine. Chlorine is in group number what? 7. Group 7, 7 valence electrons. To make it fully filled outer shell, I need a total of 8. Currently, it has 7 electrons already in the outer shell. It needs to gain 1. You gain 1 electron, 1 minus charge. So it's Cl minus. Okay, so 2 plus minus. Immediately you realize, okay, clearly this is another scenario whereby the magnesium is doubly positive. The chloride is only singly positive. The plus and minus are not the same. They don't balance out. To balance themselves out, you gotta ask yourself, okay, clearly I'm gonna need twice the amount of chloride ions. So again, 2 Cl minus ions to balance out 1 Mg2 plus ion. Okay, so this is how we write formula. Now, just to highlight, of course, if you find this whole process a bit more tedious, a quick way is once you have gotten the charges out, right? You can just cross multiply them. Meaning, the 2 plus, the 2 goes to the Cl, the 1 minus, the 1 comes to magnesium. So that's how you get Mg1Cl2. Please notice we don't usually write the 1. That's why the final answer is just MgCl2. Okay? Can? So this is how we write formula in a nutshell. The whole idea is write the charges out correctly. Once the charges are written out correctly, then you balance out the positive and negative charge. Okay? By finding out what is the number of each ion to have to balance the positive and negative out. Now, in case you are still lost, okay, what's the relationship between the group number and the charge? So let's revise this. If it's group 1, the charge is 1 plus. For example, Na plus, sodium forms a Na plus. Potassium is also in group 1, K plus. All right, so that's group number 1. Group 2, charge is 2 plus. So just now we saw magnesium, Mg2 plus. What's another group 2 element that is common? Look in group 2, there's magnesium. Below magnesium in group 2 is calcium. Calcium is Ca2 plus. Okay, so group 1, 1 plus. Group 2, 2 plus. Then group 3 there, based on this pattern, group 3, 3 plus. Aluminium is in group number 3, so Al3 plus. Okay, so these are the metals. How about the non-metals? The non-metals, group 7. The charge form is 1 minus, so like Cl minus, Br minus, I minus. So all your group 7 elements will form ions with a 1 minus charge. Group 6, 2 minus, so O2 minus. It's a good example. All right. Group 5, 3 minus, so N3 minus. Okay, so this is the relationship between the group number of the elements involved and the charge of the ion. Okay, so we have just seen how to write the formula for simple ionic compounds and how to deduce the charge on the ion based on the group number of the element. This really highlights to us that you need to have a periodic table and you need to be looking out in the periodic table for the group number of the element. Okay, now as mentioned, it is good that you learn these few common ions because these are the ones which are commonly tested at N levels and O levels as well. But now let's move on to write formula for ionic compounds that are slightly more complicated. By more complicated, I mean something like this. Magnesium hydroxide. What on earth is this? Well, definitely it's still an ionic compound because it contains a metal, magnesium. Magnesium we have just seen. Magnesium is a metal in group 2. Group 2, the charge is 2 plus. So the magnesium ion is Mg2 plus. The problem is hydroxide. Clearly, hydroxide is not just oxygen. It's called hydroxide. So clearly it's a polyatomic ion. It contains more than one atom inside this particular ion. So the formula is not just O. Neither is it just H. It's both. It contains both hydrogen and oxygen. The formula is OH. But you need to memorize the charge of this. What is the charge on the hydroxide ion? The charge is OH minus. This needs to be committed to memory. All right, so this is the next hurdle. You will need to learn the formula of the polyatomic ions like hydroxide. Because once you know the formula is OH minus, writing the formula out is very easy. because the same concept applies. The positive charge must balance the negative charge. Clearly, right now, it doesn't balance because the magnesium has a double positive. Hydroxide is single negative. Hydroxide is too weak, only single. So I need 2 times the hydroxide. So I have to have twice the number of hydroxide. I can't just write like that because what I mean is I want 2 times the whole hydroxide. Therefore, I must have a bracket. So when do we use brackets? We use brackets if there is 2 or more of the polyatomic ion. Just now, we didn't use bracket because those are not polyatomic. Hydroxide is polyatomic because there's oxygen and hydrogen, right? There's more than one atom in the ion. So the formula of magnesium hydroxide is Mg bracket OH2. The bracket is important because now you know that the 2 applies to the OH, the whole thing. Can? Now, at this juncture, let's just do a little bit of counting. Based on this formula written out for magnesium hydroxide, how many magnesiums are there? Did the 2 apply to the magnesium? No, right? The 2 only applies to what is inside the bracket. So the magnesium is 1. There's 1 magnesium. How many oxygens are there though? Then you got to think, oh, the 2 applies to whatever is inside the brackets. So it's not just 1 oxygen anymore. It's 1 times 2. 2 oxygen. How do you get 2? 1 times 2. How many hydrogens are there? Is it just 1? No, right? Again, it's 2 because it's 1 times 2. So there's 1 magnesium, 2 oxygen, 2 hydrogen in magnesium hydroxide. All right. So this is an example of an ionic compound with a polyatomic ion inside it. Now, hydroxide is not the only polyatomic ion. Another common one that you must learn is nitrate. So magnesium nitrate. Magnesium nitrate is another ionic compound. And this time around, you realize, okay, magnesium, our good friend, magnesium group 2, simple, 2+ charge. Nitrate, again, sounds really unfamiliar. It's a polyatomic ion with nitrogen and oxygen inside it. So it's NO3. And the charge is 1-. So again, you have to memorize the formula of the nitrate ion. It's NO3, 1-. Now, important to note, the 3 is not the charge. How do you know it's not the charge? Because the 3 is written at the bottom. Whenever you put numbers at the bottom, the numbers at the bottom means there are how many atoms? In this case, there are 3 oxygen atoms bonded to the nitrogen atom. Okay, so it's not the charge. The 3 at the bottom means there are 3 oxygen atoms bonded to the nitrogen atom. And the 3 must never disappear in the formula. A lot of you like to make the 3 vanish. Nope, the 3 can never vanish for the nitrate. The 3 is a fundamental part of the nitrate formula. Your final answer for the formula must still have the 3 inside it, okay? Okay, so how then do you write the formula of magnesium nitrate? You realize that writing formula means the plus and minus must balance each other out. Again, it's not balanced because Mg has a double positive charge. Nitrate is only single negative. Therefore, nitrate, too weak. You need to have more nitrate. you must have twice the number of nitrate to balance out one magnesium ion. Therefore, must use brackets. Why do you use brackets? You think again. You must use brackets if there is two or more of the polyatomic ion. Nitrate is polyatomic, therefore must use brackets to enclose the nitrate. Okay. Now, at this juncture, you might be thinking, okay, so quite clearly, you need to memorize the polyatomic ions. If you do not memorize the polyatomic ions, you will not make much progress in this particular aspect of chemistry. And this is the reason why, for those attending the lesson today, you must make it a point to learn the polyatomic ions. How many of them are there? Not too many, thankfully. So now let's list down the polyatomic ions to memorize. The first one is hydroxide. Hydroxide is OH minus. The second one we have seen, nitrate as well. Nitrate is NO3, the 3 is at the bottom. The charge though is just 1 minus. Okay, so nitrate, the charge is 1 minus. So both the hydroxide and the nitrate has a 1 minus charge. Then we move to the next, carbonate. Carbonate is CO3, 2 minus. Finally, sulfate, SO4, 2 minus. So again, you can see these two have a 2 minus charge. Okay. Now, one last one is a positive ion that you should remember. Is ammonium. NH4 with a positive charge. So ammonium has a 1 plus charge. Okay, so these are the 5 polyatomic ions that you must commit to memory. Okay, one good way to commit this to memory really is to look at it every day. Okay, once you have looked at it long enough, you will memorize it. Now, besides these ions, there are some other ions which are not polyatomic, but you also need to memorize. Okay, now I will just give you 2 of these because only 2 of these are important to memorize. The first one is zinc. The zinc ion is Zn2+. It's very important. This one is commonly tested. All right. And the next one is silver. The silver ion is Ag+. Okay, so this really concludes about 7 ions that you should try to memorize. 5 of which are polyatomic, and 2 of it you need to memorize the ion. Okay. So now we're going to move on. I shall quickly move on to covalent substances. So far we have been dealing with ionic compounds. Ionic compounds contain metals like magnesium, sodium. But now we move to the covalent substances. Covalent substances. How do you know something is covalent? Something is covalent if it contains non-metals sharing valence electrons with each other. So from the name you can tell, for example, the simple one, carbon dioxide. Carbon, non-metal. Oxide, we just mentioned, right? Oxygen. So what does di mean? Di mean 2. So 2 oxygen, therefore CO2. So obviously we will not leave space in between now. We'll just write it together as CO2 like this. Okay. So that's di. Di means 2. Okay. Next one. Let's do something a little bit different. Nitrogen trichloride. Huh? What? Right? Well, simple. You know nitrogen, non-metal. Chlorine, also non-metal. So NCl. Look for the prefix. The prefix is tri. Tri means 3. Trichloride. So trichlorine. So NCl3. Okay? Next, something very complicated. Dinitrogen tetroxide. What? Again, don't panic. Nitrogen, you recognize is N. Tetroxide, oxide, means got oxygen inside, right? Di means what? Di means two. Two nitrogen, N2. Tetra. Okay, some of you play games like Tetris. Tetris is like 4, right? Tetroxide, 4 oxygen. N2O4. Okay, so the idea is to recognize the prefix. So what is the prefix? Mono means 1, di means 2, tri means 3. Now, tetra is 4. But sometimes you drop the A so that you can pronounce it a little bit easier. So like tetroxide. So you recognize tetra is 4. Okay, the list goes on and on and on. Actually, there are more prefixes than these 4. Okay, but we'll learn this 4 for short. Okay, so this is how we actually write the formula of covalent substances. It's very easy. All you need to do is to recognize the prefixes like mono, di, tri, tetra. However, the life is not so simple. There are many covalent substances for which we do not use prefixes. Some covalent substances must be memorized again. The first one is the most obvious, water. Water, we are not going to use any other chemical name. Water is so simple, right? It's simple to pronounce and simple to spell. Water's formula is H2O. Imagine if you needed to use the prefix. It's much longer. Next, ammonia. Ammonia is NH3. Now, ammonia is very confusing because you tend to confuse it with ammonium. Ammonium is an ion. Ammonia is NH3, is covalent. Next, methane. Now, methane you have learned under organic chem. Methane is an alkane with 1 carbon, so CH4. Okay. Now, what other things should you memorize? Let me just add 3 more for you. The next 3 are your acids. Hydrochloric acid, HCl. Nitric acid, HNO3. Sulfuric acid, H2SO4. So these 3 acids must be learned. If you don't learn them now, you will realize that writing equations is a really, really big challenge. The students who can write equations well are usually those who have already memorized the formula of these 3 acids. The good news is once you have learned these 3 acids, we are very unlikely to test you on other acids. In fact, if you look at the N-level TYS questions, virtually all the equation questions will involve one of these 3 acids. Therefore, you should learn to memorize these common acids. Okay? Now, these are the 6 formula of covalent substances that I feel that you should memorize. Now, something else that you don't really have to memorize is to learn which elements are diatomic. Diatomic, once I've written out, I'm sure you will realize what I mean. Diatomic means 2 atoms covalently bonded together. For example, H2, O2, N2, these are diatomic. Right? So what is H2? Hydrogen. What's O2? Oxygen. What's N2? Nitrogen. So any of the gases ending in gen, hydrogen gas, oxygen gas, nitrogen gas, is diatomic. The next group that is diatomic, fluorine, chlorine, bromine, iodine, astatine. What do they all end in? They end in "in." Fluorine, chlorine, bromine, iodine, astatine. They are all your group 7 halogens. Group 7 halogens are all diatomic. So this doesn't really need to be memorized. You can easily deduce it from their name. So remember the gens and the ins, okay, the GEN, the INE, these are your diatomic elements. All right, so with this, we have finished writing the formula of both ionic compounds and covalent substances. Importantly, you will need to memorize some of the covalent substances. You must also memorize the 5 polyatomic ions listed just now. Okay, so from formula, now we move on. Well, formula are like words, spelling words. Now we need to learn how to write equations. Equations are like sentences that describe to you how a reaction proceeds, what happens during a reaction. Now, to write an equation, you need to know firstly, what is the reaction? Is it acid plus metal? Is it acid plus carbonate or what? You need to know the type of reaction. If you don't even know the type of reaction, you can't write the equation. Next, you need to ask yourselves, what are the starting reactants? What do you start with? Now, this is usually given to you in the question. So you must remember, in a question, highlight chemical names. Do you start with magnesium? Do you start with hydrochloric acid? All these are in the question. Highlight the chemical names in the question. Finally, you know what you started with. You need to know what you produce. What are the products at the end? Sometimes the products are told to you in the question. So again, highlight chemical names. But if the products are not told to you, you should be able to predict them based on the reaction and the starting reactants. So now let's begin with an example. The first reaction we want to go through is acid reactions. Acids have 3 types of reactions. Today, let's go through 2 of them. Acid plus metal. Acids react with reactive metals. And this produces a salt plus hydrogen gas. Remember what I said about hydrogen. Gen must be diatomic. So hydrogen gas is H2. It will never be H. It's H2. Okay? So, example. Hydrochloric acid plus calcium. If I told you I dropped calcium metal into hydrochloric acid, what's the reaction? Acid plus metal, right? Calcium is a metal, hydrochloric is an acid. So those are the starting materials. The starting reactants are hydrochloric acid and calcium from the question. But I didn't tell you what the products are. You need to know what the product is. So obviously one of the products is hydrogen. But what is the salt's name? Now the salt's name starts with the metal. You must start with the metal. The metal is calcium. The second part of the salt's name is from the acid. Hydrochloric become chloride. If you started with hydrochloric acid, you end off with chloride. Okay, so it is important to know how to name the salt. The salt's name starts with the metal. The second part of the salt's name is from the acid. You use hydrochloric acid, so it's the chloride. The next part is once you have figured out what is the product, you need to translate this into chemical formula. This is where your memory work has come in. If you remember what's the formula of hydrochloric acid, you can start. But if you didn't remember the formula, then you cannot start. So the formula of hydrochloric acid is HCl. This is from your memory world. It's one of the covalent substances that you should memorize the formula of. Calcium. Now, calcium is from the periodic table as a metal. Notice there is no charge yet. Calcium on its own has no charge on its own. It only has a charge when it's combined with something else. And that's what we're going to see in calcium chloride. Calcium chloride clearly is combined. There is calcium, there is Cl, right? So you need to write the formula slowly. Remember at the start of the lesson, we kept saying, you must think, is this ionic or covalent? It's ionic because it's a metal inside calcium, right? So calcium chloride is ionic. Ionic means it must have charge. 2 plus. How I know it's 2 plus? Because calcium, I go and look in the periodic table, it's group 2. Group 2 form 2 plus. Then how about chloride leh? Chlorine, I look in the periodic table, group 7. Group 7, gain 1 valence electron, 1 minus. So the formula is not CaCl. This is incorrect. How I know it's not correct? Because once I've written the plus and minus out, I know it cannot just be 1 chlorine, 1 calcium. It must be 2 chloride ions for each calcium. So it's CaCl2, and don't forget your H2, hydrogen gas. Okay, so many of you do not do this step. Many of you just assume it's 1 calcium, 1 chlorine. It's incorrect. You must write out the charges, plus and minus, and balance them out. Now, once you have done that, the next part is easy. The next part is you balance the equation. You have written formula correctly. Now you need to balance equation by adding in numbers in front. You add numbers in front to ensure same number of atoms on both sides. Okay? What do I mean? You got to count atoms now. Where do you start counting? You start counting from metal. Calcium, calcium. Calcium got 1 on left and 1 on the right hand side. So same number of calcium. Okay, calcium fine. Doable. Settled. But chlorine immediately poses the next problem. The Cl, there's only 1 Cl on the left. However, there's 2 Cl on the right. You cannot have suddenly more chlorine appearing, right? Therefore, I must put a 2 in front of the HCl. In front of is the keyword. Okay? In front of. Okay, and now this is the balanced chemical equation for the reaction between hydrochloric acid and calcium. So you recognize it's important to know the reaction. It is important to know the products. Once you know the product, like calcium chloride, you need to write the formula out correctly, ensuring that you have balanced out the plus and the minus charge. The last step then is to count the number of atoms and ensure it's the same number of atoms on both sides. You start counting from the metal first, calcium. After calcium is ensured to be the same number on both sides, then you count the non-metals like chlorine, nitrogen. Okay? Do not count the hydrogen or oxygen because that one you leave it last, then you count. Proceed in a systematic order. Metal, then the non-metal. Last priority, then hydrogen and oxygen. Okay, now let's finish off with one more equation. Nitric acid plus calcium. What does it form? So now the reaction is what? Acid again. Acid plus what? Calcium. Calcium is an example of a metal. So nitric acid plus calcium is acid plus metal. Forms salt and hydrogen gas. The question is, what is the salt? So again, you recall the salt's name starts with the metal, calcium. The second part of the salt's name comes from the acid. I had used nitric acid. So my salt's name ends with nitrate. So my salt is calcium nitrate. Okay? So once you have established the salt's name, you know what is the product, then you continue. You must get this step correct. If you don't know why it's calcium nitrate, then you will need to revise. Revise how to name a salt. Okay? Now, once you have established what's the products, again, translate to chemical formula. This is again memory work. Nitric acid is HNO3. Calcium metal is Ca. Remember, calcium metal on its own, calcium has no charge. But if calcium is combined with something else like nitrate, it has charge. So this is where, again, must be very careful. Ca got charge now, no, it's combined. Ca is group 2, 2+. Nitrate is NO3, 1-. So again, many of you like to immediately write CaNO3, 1 calcium, 1 nitrate. Cannot. Why cannot? Why is CaNO3 wrong? You look at the charge. Calcium is doubly positive, nitrate is only 1-. The plus and minus are not balanced. To balance the plus and minus, you absolutely must have 2 of the nitrates. Remember, you must use brackets. Why must use brackets? Because you have 2 of the polyatomic nitrate ion. Now, once you have written out the formula of calcium nitrate correctly like this, you will get 1 mark automatically. This question is 2 marks. 1 mark is given for calcium nitrate written correctly. Ca bracket NO3 2. The second mark, of course, is to balance it. So again, how do you balance? You balance the equation by adding numbers in front to ensure same number of atoms on both sides. 1 calcium, 1 calcium. Calcium is balanced. Don't need to add number in front of calcium. But the nitrate is the next problem. I have 2 nitrates on the right-hand side, but I only have 1 nitrate on the left. So again, I need to have twice the amount of nitric acid. So I add in 2 in front of the nitric acid formula to balance the equation. And this is the balanced chemical equation for the reaction between nitric acid and calcium metal. Okay, so Mr. So has written out the wrong formula and crossed out so that you don't repeat this same mistake. Okay, obviously for your final answer, you don't write the wrong formula. You write the correct formula only. All right. Now, with that, today we have really gone through how to write the formula of ionic compounds and covalent substances. We have also gone through the first acid reaction, which is acid plus metal forms salt and hydrogen gas. We have gone through how to balance the equation by adding in numbers in front. And this is the purpose of ensuring you have the same number of atoms on both sides of the equation. As you can see, to write an equation is not difficult, provided you follow the steps. Steps meaning, do you know what is the reaction? Do you know what is the starting material? Do you know what's the product? And how do I write the formula of products? So be patient, ensure that you write out the charges as we have done, ensure that you cancel and balance the charges out carefully. All right, and that brings us to the end of today's revision lesson on formula and equations. So I shall stop the recording here. Thank you.